Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, I'm going to be looking at my predictions for 2022 right after this. Just like last year in 2021 and the year before in 2020, I'm going to be looking at a number of areas, such as predictions for AMD, ARM, Intel, NVidia. I am including software again in this one, and I'm adding a new one for Linux. So let's get started and talk about what some of the things I'm going to be trying to guess on. So obviously, I'll be looking at CPUs from AMD, ARM, and Intel. Again, I think Risk 5 should be on this list at some point, maybe next year. But they're just not in the running. I mean, they are focusing on IoT. So, and that's fine, but that's not where I'm interested in producing my predictions for. So that's why they're not on the list, if you're wondering about that. GPUs, AMD, NVIDIA, and Intel. And then software. And there are some new GPU manufacturers that are entering the market from China as well. I'll probably cover those in a separate topic. I mean, they haven't really established a market share just yet, but there are some competitors coming and entering the field. Also, software again, and then Linux. So, Threadripper, we skipped 4,000. I think it went poof. I don't know where 4,000 went, but yeah, we're already talking about Threadripper 5,000 now. That is going to be a Zen 3 plus architecture. It is currently thought to be releasing in 2022, of course, with all things you don't know. I don't know if it's based on Milan architecture, or Milan X, or Genoa. I mean, Genoa is coming also in 2022. So I don't know. It is a 5 nanometer die. The clock rates at this point are unknown. We believe the number of cores that it will have is 64 cores and 128 threads. So not a lot different from the WX. Could it support 128 cores? I think that would be very expensive. But I mean, for a workstation, it's hard to say. You can't say, well, gosh, I wouldn't know what to do with 128 cores, because I guarantee you, as soon as you say that, somebody will write some software that uses all of it. So yeah, who knows? Cache memory is 256 megabytes of L3 cache, and that is huge. TDPs, we don't know, but I'm sure they'll be large. It is supposed to support DDR4. That could change. I mean, who knows? And PCI 4 with 64 lanes. The socket is TR4 currently, but it could be TR5. Yeah, I just don't know. I mean, that's pure speculation. So don't know. AMD Zen Plus. The release date, now, again, Zen 3 didn't even release. It's like, where did it go? So, but we're talking about 6,000 series and 7,000 series possibly appearing for next year in the Ryzen family. And that release is currently slated for early in 2022 for the Ryzen 6000. And that would be the Rembrandt series. Those dies could either be 6 or 7 nanometer plus. And I think on the roadmap originally, I think it was supposed to be 7 nanometer plus, but TSMC does have a working 6 nanometer die. They also have 5 nanometers. As to which one it'll actually be, I don't know. Of course, I don't think there'll be a whole bunch of different changes to this 4 to 16. Could it go higher? Yeah, it could. I mean, it could, but I think they'll wait. I think AMD will wait until the 7,000 to release additional cores. TDP don't know. PCI Gen 4 at this point. Haven't heard anything about it supporting Gen 5. Memory, we believe it will support DDR5. And we do know it also is taking a new socket. So, yeah. What about the Zen 4? Zen 4 release date currently slated for the end of 2022. So that's the Ryzen 7000. It would be unusual that AMD would release 2 series of CPUs in a year, but I think Intel will put pressure on AMD again, and in the coming years. So I think, it's possible that in order for AMD to I mean, they're going to catch up with Ryzen 3 Plus to the 12th gen, but there is a planned release next year by Intel, so they'll have to have something that answers it. Whether or not it'll move to the first quarter of 2023, I guess we'll see. But that is supposed to be a 5 nanometer. It is, again, 4 to 16 cores as far as we know. We don't know the TDP. It could be Gen 4 or Gen 5, but we do know they're going to be pushing 28 lanes with that. Now, currently, I think it's 24, I believe. Again, DDR5 and AM5. On the server side, there is a Zen 4 architecture that is slated for release in 2022. I don't think it will be early in 2022, probably more toward the end, probably third quarter or even fourth. That is based on AMD's EPYC server Genoa architecture. That is a 5 nanometer die. I have no idea what the clock rates will be. We do know that it'll be at least a 96 core with 128 core arriving in 2023. So, yeah, I mean, I think they're going to wait and release it'll be I think a Zen 4 Plus release for 2023. At least that's what I've been able to glean. Cache unknown, TDP unknown, memory DDR5, don't know the speed, possibly 4.8, although there is higher speed memory coming. So PCIe 5, TR5, the interconnect is CXL, cost astronomical, I'm sure. As far as ARM is concerned, we have Neoverse Poseidon that's planned, and that is for the N2 and E1 processors. That will introduce a new mechanism that supports mesh networks to connect the CPUs together. So it'll support, now this says N2, V1, and also E1, and that die could be 5 or 3 nanometers. Not sure yet which one it will be. Again, they're quoting 128 plus cores, but it could be 256 or 512 with mesh. So, yeah, who knows? It could be huge. This is supposed to support up to 144 nodes per die in a 12 by 12 matrix. So that's a lot of machines to be able to stick on a mesh network and share data between them. 3 to 5 devices per node, supports DDR5, not 55, DDR5 or HBM memory. There are counts for 32 CCIX devices per port per die, and if you don't know what that means, CCX is used as the mechanism to transfer information and data, applications, programming code between processors. So that is an open standard that is being widely adopted today by almost all of the manufacturers. So it'll be interesting to see where this actually goes, because in essence, CXL means that I could put a diversity of processors on a bus and support transfers of data and applications between them. So yeah, it's kind of an interesting idea, but because it's an open standard, it is possible that could happen. Memory access protection, of course, we're seeing more and more security type features that are being introduced directly into the CPU cores. Now, is that good or bad? Don't know. Only time will tell how well that's going to work out. Security takes a while to vet. So ARM server CPUs, I'm talking here about the ones from Ampere. They're going off on their own. So, and doing designs on their own now. They were basing their stuff on Neoverse, but maybe they're concerned about NVidia. Maybe they're concerned that Neoverse is going in a direction that they don't want, or maybe they are looking to compete, their machines at a higher level with AMD and Intel, and maybe they just feel that the Neoverse is not going to give them what they want. But whatever the reason, they're off and they are doing things on their own. Now they're claiming that their next generation servers will be faster than Intel and AMD. Now that's a claim. So we'll see if that's true. It's a 5 nanometer die, PCIe Gen 5, could be 6. 6 is slated for release sometime coming up. I don't know the exact year that PCIe Gen 6 is coming, but it's HBM3 or DDR5 at the moment. They use the fabric for CCIX 2.0 and CXL 2.0. That again is an open standard, which we just talked about. Cores 128 plus is all we know. Cache size, all they'll say is large. I mean, I don't know what that means. It could mean 256 meg, could mean 512 meg, but yeah, it's going to be huge. As far as the ARM chips on phones are concerned, the smaller machines, those are ARM Macula. It says Kua, but that's not right. It's a KALU. That is a 64-bit only CPU, and its performance is expected to be about 20% more than the present Cortex A78. So one of the things, yeah, like I said, the older chips had a built-in 32-bit mode, and of course, whenever you're carrying baggage like that, you're using up transistors that you could be using to do other things. And so, yeah, in this version of the ARM core, 32-bit is gone, so it's history. Which is, that's a good thing, because if you can get to pure 64-bit operations, you're handling larger segments of data, you're processing. I mean, yeah, it's going to take a little bit more memory, but hey, what doesn't? So they're looking at a die size of 5 nanometer, possibly 4. TSMC will have a 4 nanometer process available next year. And I think sometime in late 2022, their TSMC is planning a 3 nanometer die as well. So yeah, wait and see what happens there. Intel CPUs. Intel is planning Raptor Lake. That's scheduled for release in late 2022. It most likely will be a 10 plus nanometer. I don't think they're going to be able to use the 7 nanometer process just yet. It may be, but this is all guesswork on my part. It's supposed to have 8 performance cores and 16 efficient cores, and that will, of course, give you a total of 32 threads. Now, that's at the maximum. There's also lower level machines that are planned as well. So Raptor Lake, of course, is a desktop CPU, not a Xeon. So this would be the Core i3, i5, and i7, and i9. Clocks, don't know. TDP, don't know. Chipset, it will be a new chipset, 700 series. PCIe bus 5. That possibly could support Thunderbolt 5. It's not announced yet. Thunderbolt 5 is not an actual released spec, but that could be announced at CES 2022. So we'll wait and see what happens there. Memory DDR5 at 5300 megahertz. So yeah, it's climbing up there, and then it's supposed to have the Xe graphics, which is now called ARC. Built into the CPU. Now, one of the things that I did see in one of the Intel, I think it was their architecture, one of their architecture days, they are talking about there's some advantages between if you pair up, this is like control of the ecosystem again. So if you pair up one of their desktop CPUs with Xe graphics built in, and you also have an Intel discrete graphics card, hopefully by then they'll be shipping, but if you pair those two up, they will offload some of the work, like say you're streaming, and they will offload some of the streaming tasks to the inbuilt GPU, and then use the main GPU, the discrete GPU, for rendering. So it's that is, and AMD is doing the same thing. So where does that leave NVIDIA? I mean, NVIDIA currently, they have not solved the problem with ARM yet. They haven't really bought them yet. So they're left hanging. They don't have a CPU component that they could do this with. So NVIDIA could be on the short end of the stick if that ARM deal falls through, because they won't be able to offer anything to answer both Intel and AMD, which of course have CPU platforms as well. And with integrated graphics, I mean, the APUs on AMD is also talking about similar type of things where they'll be offloading graphics workloads to the, so they'd be like lower execution, lower demand type GPU interactions that would be necessary for things like streaming and all that. So, yeah, I mean, it's going to be that'll be an interesting year to see how that all pans out. Also on the server side, the Intel Xeon Sapphire Rapids was delayed I think it's been delayed at least once, and it got delayed until the first quarter of 2022. Intel, this is what they have announced. They have said that by the end of the first quarter, they'll announce Xeon Sapphire, and then they're planning the production release sometime in April. So that is a 10 nanometer process. It's up to 40 cores. Now Intel currently only supports up to 28 in the existing Xeon platform. So the clock, don't know. TDP, don't know. Chipset, unknown. It's PCI 4 bus, 64 lanes. Supports a lot of memory, 6 terabytes of DDR4. But sadly, this architecture will not be competitive with AMD's Milan X third generation server CPUs. So, yeah, I mean, Intel is still on the outskirts looking in. So yeah, they're it's going to take them a while to catch back up. I think, at least in the server market. But don't count them out. They're working on it. So I know they're working on it. AMD RDNA 3 release date 2022 is what I'm saying now. So that's 7+ nanometer or 5 nanometer, and that's supposed to be on the roadmap for CES 2022. And of course, it's always the performance per watt that determines the viability or the push for performance on CPUs and GPUs both. So, yeah, it's supposed to be 50%. It could be higher from what I'm seeing. Some of the predictions are saying it could be 1.3 times higher than current generation graphics cards. But, that's all theoretical. Who knows? We'll see when it actually appears. The Hopper architecture, I believe that NVIDIA they may be bypassing this and going straight to Loveless. So the Lovelace architecture. So we'll see what happens here. But I think I just moved it forward. So I don't know what their intentions are to do. Again, I don't have any. I don't have a telescope that points into NVIDIA and I can use to spy on them. I don't know. So 5 nanometer TSMC or 5 nanometer Samsung is still a decision to be made. I think that in the past, NVIDIA has kind of done both, like on the mobile versions of the NVIDIA chips, like on the 3070, 3080 series, they have used Samsung, and then on some of the desktop ones, they've been using TSMC. So, and there was some problems, as you probably remember last year with the Samsung one. So, yeah, so that will bring the end of monolithic GPUs when that comes, and those will be replaced by multi-chip modules, and then we're going to start seeing chiplets appear on GPUs as well. Yeah, the discrete graphics, we're expecting that release in first quarter of 2022. Don't know what will be coming on the follow-on to that. I do know there is a roadmap. I've seen the roadmap. And I'll show you some of the video as I'm doing this today. That could be announced at CES. It's a 7 nanometer die, of course. It's supposed to be 2 times over Gen 11, but that's old news. That Gen 11 was a long time ago. Supposed to have ray tracing support, and of course, again, it's the Cray Aurora supercomputer is dependent upon that. So whenever it gets released, it gets released. Some thoughts, but as long as crypto mining remains economically viable, that is, that the Bitcoin realm is continuing to grow, I think GPU availability will remain in short supply because there are a number of crypto coins that can use GPUs for their computation. I think global supply chain delays are going to continue well into 2022. I don't think that's going to be much of a guess. However, you may see crypto miners start to sell off stock from 2020. So some of the 3000 series NVIDIAs and 6000 AMD graphics boards may show up as they sell off those GPUs in favor of new designs. So, but do you want one of those cards that have been beat to death? I don't know. Software. So one of the big concerns, is, of course, is security. And this is a report from MITRE, which does a lot of the analysis. They control the database for the computing vulnerability evaluations, the CVEs. They also control the remediation that's done with the security software. In order, after they've done an audit, they have the scripts that do remediation to go in and actually fix the problem, whatever the exposure is. So they've been around doing this sort of thing for over 30 years. So they've been doing this a long time. They're saying that there's additional technology that's going to be needed to secure what they view as an ever expanding attack surface in 2022. I mean, they see all of these things like edge and cloud and all of the different layers that are going in to support data and all of big data and all those things, AI, machine learning. That's just creating this huge attack surface, and there's going to be some needs beyond some of the simple tools that were deployed in the past. So they're seeing their recommendations are that they want to see more deployments in security focused artificial intelligence because, looking through a pile of logs, doing it with a human, that's too time consuming, and humans are prone to errors when trying to read long lists of boring data. I can't think of one security person that was ever really excited about going through and looking through the security logs. Uh, yeah, they usually had tools that would help them do that. Now, AI would definitely help, especially in the larger and larger server nodes where you have facilities with thousands of servers. I just can't imagine how much fun that would be to try to go through a log manually. So also they see the use of real-time software to help identify security intrusions and intrusion attempts. So, and that would be in conjunction with AI and machine learning. But Miner says that we really need a security fabric platform or a cybersecurity mesh architecture because the load that security is going to place on each server is in itself going to expand the footprint. So, I mean, anytime you put additional software on a machine, you increase its vulnerability. So, even the security software can increase a server's vulnerability. So, they're really saying, well, we need to move that off and monitor the systems from afar, sort of back away and don't impact the servers and don't increase their security footprint, but still monitor them and watch them. It's an interesting idea. So, some thoughts on Linux. Yeah, 2022 will not be the year of the Linux desktop. And I think, and this is kind of on the darker side, Linux botnets will be deployed more and more in and trying to gain access to systems or to slow them down, to crash them, la di la di la di. I also think that malicious Linux binaries will be a bigger issue on Windows, simply because it's a vulnerable architecture. And now that they're allowing, through WSL, the graphical user interfaces and the normal commands that under Linux to run, it's just another vector to insert malware into Windows. It's also a vector they can insert malware into Linux. So, I mean, don't think that Linux isn't going to be free of this either. I think we'll start to see more and more of that as well. The Linux market share, I think, it's going to continue to expand. In fact, its projected growth is to double within the next year or two. So, and that's all because of the focus on additional edge computing devices. Those, of course, will more than likely be Linux. The use of Linux hosting virtual machines is expanding. I mean, I found that kind of interesting when I saw that instead of going containers, a lot of places are going VMs, and I think the reason for that is that the VMs give you an extra layer. Now, they might be running containers inside of those VMs, but it just gives you one more layer of protection that you don't get with a pure container. So that could be the reason for that. I don't know, but IEEE, which I think is the one that did the study, said that they think that there'll be a whole raft of startup companies to help corporations in the cloud set up these virtual machines with whatever they need in order to be able to support their environments going forward. The use of Linux on embedded systems is additional growth for the Linux market share. in the server market. Now, this that doesn't have anything to do with desktop. So what about desktop? So there is a definite focus by System 76, Ubuntu, Red Hat, and SUSE. Um, and of course, that would then sidechain Debian into this as well. But to focus on an advanced version of a Linux desktop, making it easier to use and adopt. We already have seen some movement by 76 to do that. We are seeing some movement by Ubuntu to also do that. So just some closing thoughts. Like I said last year, it's difficult to predict the future when you're looking from the past, which will be the past anyway. But I think security needs are definitely to be more of a focus for developers than open source binaries for Linux and for Windows that are going on Windows. ARM will continue to make strides toward the server dominance in 2022, but I don't think they will make it. In fact, I know Ampere is doing a heck of a lot to try to help that cause along. But yeah, AMD is going to remain the leader at least through 2022. I don't know what will happen in 2023. ARM has according to their roadmap, has a pretty big leapfrog that they're attempting there. So I don't know. We'll see. AMD and ARM will continue to make strong computing inroads in all areas: mobile, desktop, server, and HPC. Apple Apple is scaring the hell out of Intel and AMD both right now, because when they saw that chart, I'll bring it up when we're talking about this. But when Apple showed that chart about the amount of power they need to draw for the same amount of performance, I think Intel and AMD went, "Oh my God." Because that has implications all across the board for, hey, if they can get that kind of performance with that low of power, what are they going to do if they bring their power curve up to where we are? So, yeah, I mean, that's a possibility. But Intel will be battling AMD for game dominance again in 2022. That's going to go back and forth a few times here. Hopefully that will continue. It's good to see that. I remember back in the early days between AMD and NVIDIA, they would seesaw pretty evenly. One year would be AMD on top, next would be NVIDIA, next would be AMD. They just did that off and on until until NVIDIA just passed them up in dollars, and AMD just couldn't. It's hard to compete with large companies that have unlimited budgets they can throw at the problems. So, yeah, I said Intel would remain uncompetitive in the server market, and I for 2022 at least. So the dark side. I didn't have this here last year, but I think it's kind of interesting that we should probably talk about it a little bit. So the top IT issues. First is security cross-cutting issues. That is trying to balance security with privacy, and of course they are mutually exclusive. Trying to manage security is invading privacy, and trying to maintain privacy is something that will impact security controls. So, yeah, that's not a happy marriage, and so that needs to be dealt with. There's a growing movement among the open source community for intellectual property, and so yeah, people are beginning to ask, who owns the open source? I mean, who actually owns it? Does the distribution own it? Does the developer own it? Sustainability. As we explode the edge, we're going to be increasing our needs for energy, and that's a problem. That's a problem because most states in the U.S. don't want to build additional power plants because they know that there's going to be government regulations that are going to come down and put them at financial risk on those facilities. So, I mean, that's just not a good thing. I mean, having our energy needs explode without being backstopped by an energy source, that's a problem. Because then it draws from the pool of fossil fuel, right? So, and that's limited. That is a finite resource. Anyway, not to get on that bandwagon. So massively online open courses are starting to siphon students away from traditional universities. I don't know if that's a good or a bad thing, but I mean, we were hoping to do that when I was working on Plato. That was the whole purpose, was to siphon off students from the traditional educational institution. So, yeah, I don't know why that's a problem. That was the whole design goal from the beginning. Because, yeah, we were trying to reach kids that would be susceptible to dropping out. So, yeah, that was the whole idea behind it. Anyway, quantum computing. Commercial quantum computing is itching its way along into breaching viability. So it's starting to come within reach. We still got a few years to go, but yeah, it is starting to come within reach. Networking. There's always new internet technologies and always new research that needs to be done. In terms of networking, like I've said this many times. TCP/IP, the whole model is ancient and needs to be upgraded in order to support the speeds and feeds that we're attempting to do. The amount of packet size that's traversing the network is based on a 56K dial-up modem. So, I mean, that just seems, from an engineering standpoint, it's like, why? Yeah, so anyway, that needs to be updated, and I think more research needs to be done there. 3D integrated circuits, we've seen the first implementations of that with the Milan X architecture, where they are stacking additional layers onto the die substrate. So instead of being just one big linear platform, we're now starting to see layers. And that trend is going to continue, yeah. Otherwise, you're going to have chips this big. Universal memory. This is one of those pipe dreams. And universal memory is attempting to combine all the features of the best of DDR, SD-RAM, and non-volatile RAM into one universal memory. No one has achieved it yet. There isn't any technology that can do it yet, but they're still working on it. When and if that happens, that will be a huge shift in the way we do things. Multi-core will be everywhere, from phones, cars, wearables, cameras, homes, cloud servers, exascale. And then a lot of other changes there's a lot of issues in AI, machine learning, life sciences, 3D printing, you name it, that need to be solved. So yeah, those are going to be huge issues for IT in 2022. At least I think so. So that's my predictions for 2022. And when we get to November and December of 2022, I'll talk about what I did wrong. Hope to see you again soon. If you did like this video, please like and subscribe. Bye for now.